Hello everyone, welcome to Hope's class. Today we will look at the Squeeze Theorem. The Squeeze Theorem states that if I is an interval contains a point A and gx, fx, hx are functions defined on I, then we know that if gx smaller than fx smaller than hx and limit of gx equals to limit of hx is L when x approaches A, then we can conclude that the limit of fx is L when x approaches A. Okay, let's look at one example. Consider the function gx is x and fx is sine x. Sketch its graph and determine the limit fx over gx when x approaches 0. The graph for fx and gx are shown here. As we can see, both functions approaches to 0 as x approaches 0. Moreover, the closer we get to the origin, the more graph overlaps. If we apply the limit directly and substitute x is 0, we get the indeterminate form 0 over 0. We need to remove the indeterminate form. However, it is difficult to do it algebraically, so we need to use the Squeeze theorem. Okay, preview. Let's do some preview in the unit circle. Unit circle means all the radius of the circle is 1. According to the primary trigonometry ratios, we know the BE is sine theta, OE is cos theta, DC is tangent theta. Label all this information on the graph and determine the area of the triangle OBC and the area of the triangle ODC. We can find the area of the sector based on the fraction of the sector compared to the whole circle. Okay, proof. According to the graph, we can see that the area of the triangle OAB smaller than the area of the sector OBC, smaller than the area of triangle ODC. Substitute the expression for this area. Remove 1 over 2 and divide by sine theta for all terms to get a 1 smaller than theta over sine theta, smaller than cos theta. Apply the limit to all parts, evaluate the limit, and then use the Squeeze theorem to determine the final answer is 1. Thank you. For more information, please search Toronto Teacher Hope in YouTube.